um, we have realized by now that the standard form gives us a lot of information, right? And we can see where the vertex is, which is an important point, and we can find the zeros even if these are like zeros that come with, say, numbers that have radical included in them, so it is a good way of basically having the function, or a good form to have the function in, right? Where the general form, which is an ax squared plus bx plus c form, only gives us the y-intercept, right? Or we can see the y-intercept. That's the only information that we can get from it. If it is factorable, we can find the zeros. But if it's not factorable, then we have a hard time like finding the zeros through that, right? Later on, we'll find like a different way, but right now we don't, right? So the standard form is the preferred form, definitely. So now we want to change the general form to standard form to simplify the process of finding the vertex, right, and finding the zeros. And that's called completing the square. To be able to do that, we need to sort of go through some preliminary steps, right? Those preliminary steps depend on the things that we've done before. We've done them before in our like lessons, and we've done them before in like previous grades actually. So we're going to go through all of those steps that help us with that. So if you want to take a note of all of this, you can go ahead and take a note. And we're going to sort of start doing this by like performing the perfect square, right? So we want to expand the following perfect squares. One thing we can do, which is kind of like grade 9-ish, is to FOIL this, right? To go x plus 1 times x plus 1 and then FOIL it. But we're not grade 9 anymore, right? We've already done this. Square the first term, twice the product of the two terms, right? And square of the second term. We already know the result is going to look like that, right? So that's exactly what we're going to do. We're going to take x, we're going to square it. For the middle term, we look at twice the product of x and 1. And for the third term, we're going to look at second term squared. So squaring a binomial, that's what we do. So this becomes x squared plus 2x plus 1. Yeah? Squaring the first term, twice the product of the terms, square of the second term. Go ahead and do part B and C yourself. So, take the first term, square it, twice the product of first term and second term, plus second term, square it. Becomes x squared plus 8x plus 16. Next one. And I'm going to do the same thing. Take the first term, square it, plus twice the product of x and 6, plus 6 squared. So this is x squared plus 12x plus 36. Okay, so we do have a procedure, right, for squaring a binomial. Now, what if we have trinomials and we want to factor them? We notice something. The first term is a perfect square. The last term is a perfect square, right? The middle term, twice the product of square root of this guy and square root of the last guy, right? So I'm going to write it this way. This is an x squared This one is a 3 squared. And notice that first. First term is a square, last term is a square, right? And the middle term is twice the product of 3 and x. If that's the case, what do I write this in a factored form? X plus 3 to the power of 2. And that's the factored form. These are perfect squares. First term is a perfect square. Third term is a perfect square. Middle term is twice the product of the square roots of first and third. Right? So we can factor them. We can factor them as perfect squares. Right? Okay. Go ahead and do part B and C yourself. So I'm going to look at this again. I'm going to go, okay, this is x squared. The last term is 5 squared. The middle term is twice the product of x and 5. Right? So if that's the case, I can see this is a perfect square. Then this is x plus 5 all squared. Last one is a bit tricky. I can see the first one is a square. I can see the last one is a square, right? But the middle term is negative. So I'm going to rate it as plus. Twice, is it twice the product of 7 and x? Not quite, but it is twice the product of negative 7 and x, right? But and negative 7 squared is also 49, right? So I can say, okay, this is x minus 7 squared. So it is a perfect square, but with a small twist. Yeah? All right. Now I'm going to look at something that's getting closer to what we want to do. What is the value of k if that trinomial that we're looking at, which is x squared plus 10x plus k, is a perfect square? What we just saw was that, okay, the middle term is supposed to be twice the product of the first and the last one, right? How do I find out what this is? How would I find out what this, like, if I were to find out what that is, what would I do? I divide it by 2x, right? Good. So I'm going to take this middle coefficient, right? I'm going to take that middle coefficient, 10, and I'm going to divide it by 2. I'm going to get 5, right? And I'm going to take that 5 and I'm going to square it. And I'm going to get 25. And I'm going to assume that k is equal to 25. So, if it is a perfect square, divide the coefficient of x term by 2 and square it. Right? Because that middle term, the x term, is twice the product of the first term and the last term. So if I divide it by 2, I'll be fine. So I'm going to do the same thing for this guy. Negative 40 divided by 2 is equal to negative 20. I'm going to take negative 20. Notice that I'm like very careful not to forget the negative, all of that stuff, right? I'm going to square it. That's equal to 400. Therefore, k is equal to 400. You guys do part C. Go for it. Okay, I'm going to follow through with the method that I have. Like, okay, I'm going to take 21 and I'm going to divide it by 2. Well, that gives me decimal. So I'm going to rate it as 21 over 2. Right? I'm going to take that 21 over 2 and I'm going to square it. What do I get? 441 over 4. Therefore, k is equal to 441 over 4. It doesn't have to be a whole number. What is it, Adi? All right. So now we're going to move into completing the square, which is our objective. Okay. To easily determine the vertex, we change general form, which is y equal to ax squared plus bx plus c, into standard form, which is y equal to a times x minus a squared plus k. We want to find out where the vertex is. We want to find out where the zeros are, right? Or solve for the zeros quickly, right? Part 1, when a is equal to 1. So if this is ax squared plus bx plus c, right? That means that coefficient of x squared is equal to 1. So if a is equal to 1, we're going to look at an example where a is equal to 1. In this case, y equal to x squared plus 6x plus 8, a is equal to 1. We want to change this into standard form. So we're going to follow a certain number of steps. Go ahead and rate the steps. These are important steps. Okay. So we're going to separate the terms that have the variables in them, and we want to leave 2 blank spots with a plus and a minus sign. So you're going to take x squared plus 6x, those two have variables in them, plus something, plus a blank space, minus a blank space. I'm going to rate that. For this to be a perfect square, what do we need to do to make it a perfect square? Divide this by 2. So that's what we're going to do. We're going to divide that middle term, or divide coefficient of x by 2. 6 divided by 2 is equal to 3, right? Take that 3, square it. We get 9, right? Put that squared number that we have. Take that squared number that we have, which was 9, and put it into the blank spots. 9, 9. Now notice something. If I have, say, 3 plus 4, that's equal to 7, right? Yeah? If I have 3 plus 4 and I add 9 to it, what is that equal to? What if I take away 9 from it? Still 7, isn't it? So by adding and subtracting the same amount, I'm not changing anything, right? I'm just changing the form of it. So I'm going to do that. I'm going to change the formula by adding and subtracting 9. So separate the first 3 terms. X squared plus 6x plus 9. This negative 9, I'm going to leave it outside. Plus 8. Now, by design, this x squared plus 6x plus 9 is a perfect square. So I get x squared plus 3 squared. It has to be square. I made it to be square, right? There's no way that it cannot be square. Minus 1 outside. Is this in standard form? Bingo. Y is equal to x squared plus 3 squared minus 1 is a completed square form. Sorry, this is an x here when we factor it. Okay? So that's a completed square form. So these notes are important. Make sure that you write these notes down. Those are the important parts of this. So a is not equal to 1. We want to complete the square for this 3x squared minus 12x plus 11. Oh my God. Oh my God. right? Separate terms with variables and factor coefficient of x squared. One extra step. Oh my God. Is this? So I'm going to go, this is 3x squared minus 12x, separate it out, plus 11, factor out the coefficient of x squared, in this case 3, x squared minus 4x plus 11. Leave 2 blank spots inside the brackets. So now we go inside the brackets, do whatever we did to the other one inside the brackets here. But I'm going to add square brackets here. You should do that too. I'm going to go x squared minus 4x plus a blank spot minus a blank spot. Square bracket closed, plus 11 on the outside. Divide the coefficient of x by 2 and square the result. Put the squared number in the blank spots. Alright. Negative 4 divided by 2. Negative 2. Negative 2 squared is 4. And you go, okay, this is 3x squared minus 4x plus something minus something, square brackets closed, plus 11 plus 4 minus 4. By adding and subtracting 4, I'm not changing anything. I'm just changing the form of it. Separate the first 3 terms inside brackets. So now that's why I have square brackets. I'm going to go, okay, inside the square brackets, I'm going to take the first 3 terms, x squared minus 4x plus 4, and I'm going to put round brackets around it. Minus 4, square bracket, plus 11. Complete the square with this guy. By design, this is a what? A perfect square. This is an x minus 2. See this minus 2? That's where it's coming from. X minus 2, all squared. 3, square bracket, minus 4, plus 11. Now I want to distribute this 3 over what's inside the square brackets. So this becomes 3 times the first term inside the square brackets, x minus 2, all squared, 3 times negative 4, negative 12, plus that 11 that was sitting on the outside. After we've done the distribution, right, we simplify. 3 times x minus 2 squared minus 1 is the completed squared form. We put it in a box, we celebrate, and we call it a day. Post